This is Tech Tip number 1, covering soldering guidance and tips for the new or novice user. We will be covering soldering iron selection, accessories, consumables, and techniques. So if this interests you, stay tuned. Alrighty, let's get in this. So if you're going to learn how to fix stuff, particularly electronics, you need to learn how to solder. In my early years of messing with stuff, soldering was a disaster because I didn't know and understand the basics. My biggest issue was the soldering tip never seemed to get hot enough to melt the solder. That was because I didn't know about tinning the tip. And basically, it's just a coat of solder on the soldering tip, and that keeps it hot. If you don't tin the tip, oxidation forms, reducing heat transfer to what you're working on. The solder forms a protective layer, preventing oxidation of the iron-nickel plating that's on the tip, and it ensures efficient heat conduction and creates a low melting point surface for the solder to adhere to. It also facilitates proper wetting and flow of the solder for strong solder joints. So the first thing you need to do with your shiny new soldering iron is tin the tip. And with this big soldering iron, for demonstration purposes, hopefully you can see there's solder on the tip of it. So the next thing you're going to need is some solder. And I use this 63% tin, 37% lead rosin core solder. It's made by Kester, and I use the 0.8 millimeter diameter wire. I mean, you can use any diameter you want. I just find this works for most applications. The number of the Kester is 24-6337-0027, and it's very easy to use, performs very well, and I believe the 6337 solder is the most used solder by hobbyists in electronics, so I highly recommend it. And the solder has lead and flux in it, so it's strongly advised to use a fume extractor of some sort. The final consumable you may want to look into getting is some soldering flux. This is made by Amtech, and it helps clean the metal surfaces by removing oxides and impurities, allowing the solder to properly wet and form the strong adhesion and bonds. It also prevents reoxidation during heating and helps create a shiny, strong joint. I've recently been turned on to RMA-218 solder flux that's available on Amazon. And that's less expensive than this Amtech and supposedly works the same. So another thing you need to know about flux is it creates a residue that you usually have to clean off the board. The thing I use mostly is isopropyl alcohol and grain alcohol. And grain alcohol, I like that. It's a good general cleaner for the flux, and it's relatively cheap. And if you have a bad day, you can always take a snort. So let's go over the soldering irons I have laid out here. This one, made by Weller. This was the first one I ever bought, and I probably bought this about 40 years ago. It's a, I think it's a 70 watter, somewhere in that range, but you have to pull the trigger to heat it up, and it takes a while to get good and hot, and I just had disastrous luck working with that. Like I said earlier, primarily because I didn't tin the tip, and I just couldn't get anything to melt. And maybe about 25 years ago, I bought this one from the Radio Shack to do PCB board repairs, and I still hadn't mastered the idea of the tinning the tip, and that didn't go so good. So about 10 years ago, I figured, well, I need a new soldering iron because these two won't do anything. And I bought this one. This is, what is this one? This is another Weller, a little cheap Amazon stand. And that worked pretty good. And around that time, I did discover the idea of tinning the tip, which I know it may sound silly to those in the know, but if you're starting out and you don't know about tinning the tip, your tip never stays hot and you can't get anything done. It's very difficult. So, and then, I don't know, 3 years ago, I decided to get this Heiko FX88D, and I'll tell you what, that's the cat's meow for soldering, in my opinion. I'd only recommend investing in one of those if you're going to be serious about doing repairs. If you're just going to do once in a while stuff, any one of these relatively cheap soldering irons will do the trick. This Heiko has variable heat settings on it, and I think I have it set to 185. We'll see that later. And it has this nice stand to put your soldering iron in. And probably the next most important thing next to tinning the tip is your soldering iron tips. So let me get the close-up camera here and we'll take a look at those. This is a close-up of the soldering tips I have at my disposal, and I did forget to talk about this soldering iron. This is a 200 watter.
Oh my Lord, look at that thing.
So big.
I've seen bigger.
That I bought recently on the eBay, and that primarily I use on tube radios. If you have a ground strap that's soldered to the metal case, it takes a lot of heat to heat those up, and you're not going to do it very well with one of these regular pencil soldering irons, if that's what you want to call it. But back to the tips. So one of the things I see on videos that frustrates me when I see people working on stuff is they're using these tiny little tips when working on through-hole components, which is relatively big. The one I have on my soldering iron is I'll have to look and see what the number is, but it's about I don't know, a quarter inch. No, not a quarter inch. Three-sixteenths. It's a good sized tip. And that's what you want to use, because the bigger the tip, the more heat. And the more heat, the better your soldering's going to go. There's an even bigger one that came with the Heiko, and that one's would ideally be the best one to use, but it's just a little bit too big. These tiny ones, and I'll consider this one, and this one to be tiny. I basically just use that when working on surface mount stuff. And I don't know, a year ago I bought this little hooked pointy deal for doing surface mount stuff, and I hadn't had very much luck with it because the heat is down low. It's very difficult to get the tip to work, so to speak. You got to kind of drag the tip with your glob of solder on here and transfer it to the end there. And didn't work so good for me. So use a big tip. You'll be glad you did. Okay, the next thing you're going to need, assuming during your repair you're going to have to disassemble something or take a solder component out, is you're going to have to be able to desolder it. So there's a couple different ways to do it, and one is with this braided cord. They make cheap versions of this stuff, which doesn't seem to work as good as this Tech Spray brand. I'm not sure why, or if that's just me, but I spend the few extra bucks to get the Tech Spray. And the other way or method of getting the solder out of your component is with a solder sucker. This is what I like. This is just a little bulb, and it does a good job. And probably the most popular thing, I don't think I've ever seen anyone use one of these bulb ones on the internet, is these push button deals where you prime it and then hit the button. And I don't know why, I just never had much good luck using those. I don't know if I need to invest in an expensive one, but this solder bulb does a trick good for me. So we'll get on to looking at the different types of boards you'll be working on, assuming you're working on a PCB board. So you have your single-sided, which just has the copper on the one side and there's nothing on the back. And then you have the dreaded two-sided. And I say dreaded because it can sometimes be difficult to get the components out, especially when the high heat solder that industrial manufacturing uses to solder their components in. That can be a real bear to get the components out without really doing some damage to the board or whatever. So let's get into some techniques for desoldering here. Alrighty, we'll get on to a demonstration of desoldering technique. So we'll say you've got your brand new soldering iron and you got a sucker and some braiding cord, and this capacitor here is bad on your board and you want to remove it. So we're going to try the solder sucker on one pin and the braid on the other pin. I believe this is a two-sided board and probably has the high heat solder, so hopefully will be a good one. I'll get the camera in a little closer and we'll give it a go. Alright, this is the back side of our board, and here is the two leads we're going to desolder. So hopefully I can do this on camera without screwing it up. So we'll assume this is a high temp solder on here, so we're going to want to add some solder to here. If you're working on older electronics that doesn't have that, you don't really need to worry about it, but they do make really, I guess, ultra low temp solder. For doing this stuff, this regular stuff by Kessler, I think it's I don't remember what the melting point is on it, but I've never had to use the specialty low temp solder. I believe it's kind of pricey and you don't get a whole lot of it. So we'll just add some solder here, so don't be shy. Put a lot in there. And I just hit it a couple times to try and get it to blend in there. And we'll try the solder braid first. Gotta get a clip a fresh clean end for this. So you clean your solder tip on the sponge. You want to get all the solder off of it, or as much as you can, and just kind of wiggle it on there. And I think there's some solder on the other side. Now the soldering braid, like I mentioned, it works great. It's just kind of expensive to do if you're doing a bunch of stuff where you gotta desolder many components. You're gonna go through that stuff, so it's kind of stuck to the pad. So we're just gonna bump it, and now it wiggles. So let's try the solder sucker on the other one. So I just kind of slide it over the pin, heat it up, and it looks like it did an equally good job. And it's even loose. So you want to use as little heat as possible when doing this, because the more heat, the more chance of damage. And I guess this, I don't think this is a two-sided bore, but we'll just reach behind and pull out our capacitor. And I'm sorry it's kind of dark there, but there was a lot of reflection from the light on those silver globs, so I just made it dark, so hopefully it's easier to see. So that's the solder braid and the sucker. A lot of times, or at least I do anyway, I'll find with that solder sucker, it'll get most of it, but sometimes you have to hit it with the solder braid to get it out. And this one came out pretty good. If this board was two-sided, I don't know, I can't see the back side of it, but let's assume it is. That high temp solder, when you add solder to dilute it, the high temp stuff tends to stay right where you don't need it. And it can sometimes be a real pain getting stuff out of there. I will show you, sometimes you do get the component out, and that went well, but no matter what you do, your hole right here where the component went in, it's filled with solder. And it's tough to get out. So what I'll do is just take the soldering iron, heat the pad up, and just boink, like that, break the surface tension. And you usually don't even need to put the solder braid or anything in there. It opens it up enough that you can fit the component in. So the reverse. So we got our old cap out, and we'll assume this is a new cap. See if I can get this in here without seeing what I'm doing. All right, I'm gonna have to pause this for a second. So we got our old cap out. We're gonna put our new cap in, and I just want to off topic real quick. So you got your brand new soldering iron, and just tinning the tip is just coating it with solder. And when I turn my soldering station off, I leave the tip tinned. I'm not sure why. I don't know if I read to do that or just came up with that on my own. But you want your solder tip nice and silvery, full of solder. So to solder it in, we try and get, and this is where having a big soldering tip helps. You try and get your tip on the pad and the pin. That didn't go so good. Hard to do on camera. There we go. We got 1 and 2. Nice looking solder. Solder joints. And if you want to take a Q-tip and some isopropyl alcohol or grain alcohol and just clean that around there, you have a nice professional looking job. So that wasn't too bad. We'll get on to the next thing. I just wanted to show this real quick. So you have your two-sided board, and you just labored and labored to get the doggone component out, and you can't get the solder out of the little hole there, no matter what you do. So you take a something like a stainless steel pick, so your solder doesn't stick to it, and clean your soldering tip real good, because you don't want to add more solder in there. And I didn't do a good job of cleaning the tip. All right, so we'll heat our pad, if I can get in there, and whoop. Now we can likely fit our whatever we're replacing there, capacitor or resistor or whatever. And now that you've broken the surface tension, if you still need more room, usually the solder braid will work to get the rest of the solder out of there. But I just wanted to show that real quick, because it can be frustrating to get these holes opened up to where you can get your components in. Another thing I want to show from tube radio repair is how to solder in components in a tube radio setup where they don't have PCB boards, and it's just point to point wiring stuff together, and I have a pretty slick way of doing that, so let's take a look at that. All right, in the process of recapping this, and I wanted to show my technique, how I do the paper caps. So this paper cap here went in here. So we take our replacement cap, just roughly measure our dimensions for fitting it in there. Then I take a piece of wire and a little difficult to do on camera. Stick it in there and wrap it around. Then that last little bit that's kind of sharp on the fingers, I just take it around. All right, there we have our approximate dimensions. So then we stick it on like that. The nice thing about doing it this way is it's nice and neat. You I concentrate here for a sec. It's nice and neat. You get the added stability of using the previous wire from the paper cap, which is much heavier gauge, so it keeps keep that capacitor a little more solid. So that's how I do it. It's neat. It's quick and fast. If you need to change something, you just heat that up, pull it off. So just wanted to show that. All right. I hope you enjoyed that part. That is a slick way of soldering in components and doing a nice, neat job. The main important thing when doing that is when you clip the wires, those paper caps tend to puke wax, and you want to scrape them real good, get all that wax off so your solder sticks and you get a nice clean solder joint. And another thing, I think I mentioned the Heiko was set at 850. It's set at 750, and ever since I got it, I've never changed it. That 750 value has worked for everything I've done. And a couple other things you might want to have is a snipper for clipping your leads, and one of these holders to hold your board. And if somehow your soldering tip gets real dirty, these sal ammoniac blocks work good for cleaning your tips. You definitely want to do that outside because that makes some kind of noxious fumes. So don't do that inside. I think I've only used that block a couple times, but it's handy to have if you need it. So this hopefully will get your feet wet in your journey to learn how to repair electronics. Just like anything else, soldering takes practice. The more you do it, the better you'll get. And one other thing I forgot to mention, when you're working on the high temp solder removing components, putting flux on there will definitely help too. And usually for the through-hole stuff, you don't really need that, but the surface mount stuff and multi-pin connectors like this here is a bunch of connectors where you want to get everything hot, so putting that flux on there definitely helps. So I hope you learned something, hope you enjoyed it, and thanks for watching.